Let's solve some more problems here. So we're given this quadratic equation k squared minus 5k minus 21 equals negative 7. Again, we can solve for k here by putting all the terms to one side. So in this case, we can put all the terms on the left. So we just have to add 7 to both sides. So this would be k squared minus 5k minus 14 equals 0. And now our new equation is k squared minus 5k minus 14 equals 0. Let's try if we can factor this. We look for factors of 14 that when we multiply them, it would equal to negative 14. And when we add them up, it would equal to negative 5. So the factors of 14 are 14 and 1. Okay. And 7 and 2. So we use here 7 and 2. Since the coefficient of the middle term is negative, therefore the larger number should be negative. So this would be k minus 7 times k plus 2 equals 0. So these are our factors for this equation. And then we can set each factor to 0 to solve for k. So k minus 7 equals 0, or k plus 2 equals 0. So we add 7 here. So k here is equal to 7. And then here we subtract 2 from both sides. Then k is equal to negative 2. Therefore, the values of k here are 7 and negative 2. Okay, let's solve another problem. Okay, we have here 10x squared equals negative 11 plus 6x. Okay, so we can put all of the terms together. We can put them to one side. So let's put them on the left. So this would be 10x squared. Okay, we transpose negative 11 and positive 6x here. So positive 6x would become negative 6x, and negative 11 would become positive 11, then equals 0. Or you can always add 11 minus 6x, 11 minus 6x. Okay. So this is our equation now. Let's try if we can factor this. So we look for factors of 11 that when we multiply them, it would equal to positive 11. And when we add them, it would equal to negative 6. And take note that we have our first term has a coefficient which is equal to 10. So the factors of 11 are only 1 and 11. When we multiply them, it will equal to positive 11 if they're both positive. But then when we add them up, it won't equal to negative 6. Therefore, this equation cannot be factored, and we use the quadratic formula. So let's do that. So this is the negative of negative 6 plus minus square root of negative 6 squared minus 4 times 10 times 11 over 2 times 10. Gosh, what happened to my pen? So this is just 6. So this is just x equals 6 plus minus square root of 36 minus 4 times 10 times 11. This is 440. So 40 times 11 over 20. And this is just 6 plus minus square root of 36 minus 440 is just equal to negative 404 over 10. And then we can simplify this. Right, we can write 404 as 4, okay, negative 4 times 101 over 20. So this is just 6 plus minus, since the square root of negative 1 is just equal to I. 2I square root of 101 over 20. Okay, notice here that 6, 2, and 20 are all divisible by 2, so we can divide them by 2. So this is just 3, this is 1, and this is 10. Therefore, the value of x is, or r, 3 plus minus I square root of 101 over 10. Or you can just simply write the two values for x, which are x equals 3 plus I square root of 101 over 10, or x equals 3 minus I square root of 101 over 10. So those are the values for x. Okay, let's solve another problem. We're given here n squared plus 6n plus 10 equals 9. Okay, to solve this, we need to move all of the terms in one side. So we can move 9 to the left. Just have to subtract 9 from both sides. So this is just n squared plus 6n plus 1 equals 0. Now let's try if we can factor this. 1. Factors of 1, only 1 and 1. And it won't, when we add them up, it won't give us a sum of 6. So in this case, we can use the quadratic formula. So this would be n equals negative 6 plus minus square root of 6 squared minus 4 times 1 times 1 over 2 times 1. And this is just negative 6 plus minus 36 minus 4 over 2. So negative 6 plus minus square root of 36 minus 4 is 32 over 2. 32 can be split as 16 and 2. So this is just negative 6 plus minus square root of 16 times 2 over 2. And 16 is a perfect square. So we get the square root of 16, which is 4. So we can write 4 outside of the radical, and then square root of 2 over 2. Then notice here that negative 6, 4, and 2 are all divisible by 2, so we divide them by 2. So this is just 3, 2, 1. Therefore, the values for n are, okay, negative 3 plus minus 2 square root of 2. Oh, just square root of 2. This is already 1. So the values for our n are n n equals negative 3 plus 2 square root of 2, or n equals negative 3 minus 2 square root of 2. So these are the values for n. Okay, let's solve another problem here. We have 5v squared plus 1 equals 406. Okay, again, we can put all the terms to one side. We can transpose 406 to the left. Subtract 406 from both sides. Okay, so this would become 5b squared minus 405 equals 0. And we can divide both sides by 5 because 405 is divisible by 5. So this would become v squared minus 81 equals 0. Now we have the difference of two squares because 81 is a perfect square. We can write 81 as 9 squared. Then we can write v squared minus 9 squared as v plus 9 times v minus 9 equals 0. And then we can equate each factor to 0 to solve for v. We subtract 9 here. So v is equal to negative 9. And the other v, we add 9 here. V is equal to positive 9. So the values of v are negative 9 and positive 9.